they will have done some algebraic proofs. Yes, sir. We are going to look at, oh, did I give you 2.6? Oh, you have the wrong, oh, that's weird. You need 2.5. Anybody else have 2.6? Pass them back to the front. Anybody else have 2.6? Just this row? I don't know how that happened. It's okay. All right. I don't know what's going on there. That is strange. They were just kind of thrown in there. I don't know. Okay, let's try this one more time. Oh, I missed you. How many behind you? Because she's fine. So 1, 2, 3. Okay. Jordan. Jordan, make sure you get your homework turned in, both assignments. So do you have your homework? Okay. You don't have your bag? Can't take it late, Jordan. I mean, if you had it like next hour or something like that, but I can't. I'm sorry. It's just not fair. Okay. Everybody with me, please. Okay. So we're going to start our idea of proofs today. We're going to start out with algebraic. We'll end the lesson. Hey, girls, with me? We'll end the lesson with starting some basic geometry proofs. More of it's going to be algebra than anything, but we'll start it with some basic geometry proofs. When you do these proofs, I'm going to ask you to do it different than the textbook. Canyons are a problem? Okay, so remember when we were passing those back, we were trying to make sure you grabbed 2 sheets. Does everybody have 2 before we get going? Oh, it's okay. It's all right. No biggie. When I hand them back, I'll be like, hey, look, this is for me. Somebody else got this. Okay, so what I want to make sure you're aware of is what I'm going to ask you to do today is different than what is in the textbook. So I'm going to have us set our problems up different than what the book is going to have you do. So if you look at the book and you decide you're going to follow what the book has, you're not setting it up the way that I'm asking you to. And the reason I'm going to make you do it a little different than the book is so that when we get to 2.6, we've already been doing it the way that 2.6 is going to ask you to do. So it's consistent, it's easier that way, and you're not having to change and adjust. Okay? So we're going to start off and we're going to do 2-column proofs today. Proofs. What are proofs? Proofs are a step-by-step procedure backed up with a reason why you can do what you do. So sometimes proofs are harder for my pre-AP students than they are for my regular students. And the reason is because you think quickly. You put steps together. You're able to process faster. And so therefore you want to skip steps. And proofs are not about getting the answer. Proofs are about every single little step it takes to get to the final answer. It's not that once you get done to the bottom's your answer. The whole thing is your answer. And so if you're skipping steps, you're missing points on your proof. Okay? So that's where you have to be super careful. So that's why we're going to start with algebra, because you're used to algebra. And if you've had teachers that said you have to show every single step, this will be easier because you're used to that. If you've had teachers that are just like, if you can get the answer, that's good enough, this is going to be hard for you because you're going to have to show every single step. Okay? Definition for proof is it is an argument that uses logic, which is why we've been doing all of these sentences and thinking logically. It uses definitions, properties, and previously proven statements to show that your conclusion is true. in our proofs, we're going to be using lots of properties today because we're doing algebraic proofs. When on Thursday, when we get to 2.7, we'll be using more of definitions, theorems, postulates. My best advice, if you're struggling with proofs, is you need to spend some time in your book, and I'll say this several times, but I want to show you today, and then I'm going to keep pointing it out. If you look in the back of your textbook in this little teal green section, so far we have done chapter 1 and we are in chapter 2, right? This is where your postulates and your theorems are. And they're listed by chapter, which is nice because then you can just kind of go back here and review. In a proof, you're going to have to back up everything you say with either a definition, a theorem, or a postulate, or a property. And so if you're struggling and you're like, man, I don't know where to go or why I can do this, open your book up, go to this page, and then start scanning through your theorems and postulates. And that'll help you, if it's not a definition, it'll help you kind of review, and then maybe that'll give you some ideas of what to do next, okay? If you're struggling with proofs, most of the time it's what I've noticed in years of teaching geometry, it's not because you can't think logically. It's because you don't know your definitions, you don't know your theorems, and you don't know your postulates. And so then you don't know where to go. Okay? So best advice, if you start to struggle, especially on Thursday, you need to spend some time studying your definitions, theorems, and postulates. Okay? Okay, you cannot have your phone in your lap. I've told you since day one it has to be in your bag. Put away. It can't be in your lap, okay? You have your notes? Did I pass you? Okay, awesome. Okay. An important part of writing a proof is giving justifications. I've already said that. You're going to have to explain what you do. All right, so we're going to start with our algebra. These are properties you should have learned way back. I don't know when you learned them, but you should have learned them way back. And this is what you're going to be using as your reasons today. So basically what we're going to do is we're going to do 2-column proofs. 2-column, it's going to look like a T table. You're going to make 2 columns. You're going to have statements on the left, and you're going to have reasons on the right. And every single time you do a proof, this is how you're going to set it up for me. This is different than what the book is going to ask you to do. Again, the reason is because this is how we're going to do 2.7 when we get there Thursday. You have to label this statements and label this reasons, or I will count off points. Your statements and reasons should be numbered. So every time you do a statement, you're going to number what that is, and every time you give a reason, you're going to number what that is. And again, I'm going to give you points for numbering and labeling, or I'm going to take those away if you don't. So make sure you do set it up correctly to start with. Reasons are going to be your properties, your definitions, your theorems, your postulates. Statements are going to be your work, okay? So solving that algebra equation step by step. All right, so some of the reasons you're going to use today are going to be these properties, and we're just going to go through them pretty quickly. These 4 you should already know. It's the addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. When you write proofs, I will not let you abbreviate. No abbreviations. No abbreviations. With one exception, I will let you use symbols. Okay? So instead of saying addition property of equality, you can put an equal sign. Subtraction property of equal sign. Multiplication property of equal sign. Division property of equal sign. So if you want to shorten that a little bit where you don't have to write out addition or equality every time, you can put the little equal sign. Okay, and that goes all the way down on all of these. But you have to write everything else out, no abbreviations. Okay, so first 4. Addition property is what you do if you are adding something to both sides. So it says if A equals B, then if you add something to both sides, that's your addition property. Subtraction property is if you subtract something from both sides. Multiplication is if you're multiplying by something on both sides. Division property, if you're dividing by something on both sides. Now be careful. Biggest mistake I see is this. What is the next step to solving this problem? I'm not distributing x. What did you say? Combine like terms. So what is my next step here? Okay. What did I use to do that? Did I add something to both sides of the equation? No, you did not use the addition property. That's the biggest mistake I see is anytime students think I added, they think that's the addition property. We didn't use the addition property. We would have to add it to both sides for it to be addition property. What you said is what you used. What did you say? Combine like terms. So what we're going to add down here at the bottom that is not on this chart is combine like terms. Or if you're a little lazy like me and you don't want to write out 3 words, combine like terms, then you can write 1 word and we'll call that simplify. Because that's what you're doing, right? You're simplifying the left-hand side of the equation. So 2x plus 3x is 5x. Any questions there? Okay. So the first 4 I feel like you should know. The next 3 I think are new. And I'm not so sure that you've ever seen those before, so I'm going to come back to those in just a second. Those are probably the 3 most important properties in geometry. We're going to use those 3 all the time, not just in our algebra proofs. So very, very important. Go on down to substitution property. That's something that you should know from Algebra 1. Substitution property says if A equals B, then you can substitute B in for A in any expression. So how that's going to look if you're using the substitution property would be something like 2x plus 3y equals 14, y equals 7. What would be the next step in this problem if I wanted to solve? Plug what? Plug the 7 in for the y. So when I do that, I would have 2x plus 3 times 7 equals 14. And what I just used to get this statement is the substitution property of equality. Everybody okay with substitution property? Okay. So let's go back to these 3. These are the new ones for geometry. The first one is the reflexive property. You probably haven't used that much in Algebra 1. You won't use reflexive a ton in your proofs, just mainly because I'm not going to make you write it every time. But reflexive property just simply says something equals itself. 2 equals 2, 5 equals 5. AB equals AB. Something is equal to itself. That's reflexive property. Symmetric property, think of symmetry. Symmetric property says if A equals B, then B equals A. What did they do to the equation just there? Okay, so I love that. Good job, you. They flipped it, which is like the converse when we switch it. So good job there. I like it. So A equals B, then B equals A. So switching it there. You will use that a lot because I'm going to make you write your final answer as X equals. Most of you do that, but you don't realize what you're using is the symmetric property. So if you solve an equation, for example, let's say I have something real simple here. 6 equals 2x. What would I do to solve for x? Divide by 2. And a lot of times you guys will do that, and then how will you write your answer? X equals 3, but you have skipped a step. What you really have is 3 equals x, right? And then what you did in your mind is you flipped it over. So this is really a step in between. And again, this is where I'm telling you, when you think quickly, you're going to miss some steps. And so I'm going to try to show you everywhere that I notice steps being missed to try to stop that from happening, okay? But you will have to write it like this, where you have 3 equals x, and then you flip it over to get x equals 3. And then you will say symmetric property of equality. Yes, sir. No. So your proof is not finished until you have x equals today on every algebra problem that we do. Okay? Has to be on the left, has to be x equals. We will. And we're going to do examples together. Okay? But yes, you will. Okay, last property here that's new is the transitive property. I think of transitive kind of like a train. This is also very similar to one of the things we learned. Who said it? Say it again. The law of syllogism. This is very similar to that law of syllogism. Here's why it's different. The law of syllogism is about if-then statements. It's about conditionals. This is not an if-then statement in sense of we're going to be looking at equations. If A equals B and B equals C, then just like with the law of syllogism, we can get rid of the middleman. We don't need this B. So now we can say A equals C. This is the one that is often confused with substitution. And so I need you to look at the difference up here. We all agree this is substitution, right? Okay, so I want to show you transitive property. Transitive property says if 3x equals y and y equals 6, then 3x equals 6. This is not substitution. This is transitive. How can you tell the difference between substitution and transitive? Can you? What do you mean by the answer? Okay, so what would this be? Transitive or substitution? It's transitive. So here's the difference between transitive and substitution. Notice that this whole side and this whole side are exactly the same. This is like saying A equals B and B equals C. The entire middleman is exactly the same and we get rid of it. That's transitive. Over here, this whole left side was 2x plus 3y. This whole right side was 14. The left side was y. The right side was 7. None of those are exactly the same, right? Okay, so that's substitution when the whole side is not identical. Has to be identical. If it's identical, you get rid of it, set them equal, that's transitive. Am I making that clear? That is most commonly confused on the test. Okay, again, it has to be transitive property of equality, and you're writing it all out, no abbreviations. The last property that we're going to look at is the distributive property. I don't know why they didn't just put it on that chart, because you've used distributive property before as well. Distributive property is when you have a set of parentheses with a plus or minus in the middle, and you are distributing the A to both. Be careful. This is not the distributive property. This is just multiplication from left to right. Distributive property has to have a plus or minus sign in the middle for you to distribute. Everybody good there? Okay. And remember that it is not multiplication, addition, subtraction, or division unless you're doing it to both sides of the equation. If you're just combining like terms, you're going to combine like terms or put simplify. Okay, so we're going to do some practice problems. And the rest of the notes is basically practicing algebra and then jumping into geometry proofs. So those are the properties you're going to be using for today's lesson. When you start your proof every single time, you're going to start out today with a given equation that they're going to ask you to solve. So your very first reason is going to be given. Okay, so you're just going to write given. The equation is given to you. So when I solve this very first equation, I'm going to make a t-table. This is called a two-column proof. Left side's going to be statements. Right side's going to be reasons. And then we're going to number our statements and number our reasons. What is the statement or the equation that they want us to solve? 4m minus 8 equals negative 12. And what's going to be our reason? Given. Every single time today, that's how we'll start. We'll start with listing our given information. Now, here's how you know when you have to write a proof. If it says write a justification for each step. If it just says solve, you don't have to write a proof. But if it says write a justification for each step, then that's setting it up today as a two-column proof. Okay, here's the other thing. I don't want you to show work in your proof, okay? You have to think logically what comes next, but I want you to do the math in your head, not in your proof. So tell me what you would do first here. You can. So good question. If you want to show your work over to the side, then you can write 4m minus 8 equals negative 12. Show your work over to the side. But in your proof, you're not going to put, what did you say to do next? At 8. You're not going to put plus 8 plus 8. You're going to do that in your head or over to the side. What you're going to write is what you get next after you add 8. So when you add 8, what is your next statement? Statement, not reason. What is your next statement? Okay, 4m equals negative 4. Your statements are your processes. Your reasons are your properties, and so forth. So then you're going to ask yourself, what did you do? What property? Addition property. So then number 2 would be addition property. Make sure you don't abbreviate. And don't forget to put of equality. And the reason that's important is because in a little bit we're going to learn some of these same properties are of congruence. And you'll have to know when to use equality and when to use congruence. Okay, keep going. What's the next thing we would do to solve? Divide by 4. So again, you can come over here and do the work if you need to. So write down divide by 4, divide by 4. But you don't write that on your paper. What do you get when you divide by 4? M equals negative 1. So your next statement is M equals negative 1. What did we use to get there? Good. Division property of equality. No, you cannot abbreviate anything except equality, and that can be your equal symbol. Are we good? And then you're done because you have M equals. So that's all you have to do. That's an algebraic proof. You're writing the statements, you're giving a reason for everything you do. Pretty easy? Not easy? Let's try some more. Okay, and again, I'm making you do it different than the book. So if you look at the book, it's going to be set up a little different and they're going to show their work. We're not showing our work. We're just showing the next step. Okay, so again, solve the equation, write a justification for each step. So make a T-chart, statements and reasons. Make sure you're labeling at the top, statements and reasons. And then number every statement, number every reason. That's important just for where we're headed. Okay, what's the first thing? What's our first statement? 1/2 t equals negative 7. We have to write down our equation, and what's my reason? Given. And if the little points get in the way or you start to think that that's part of your equation, be careful. You may want to use little parentheses. All right, what's the first thing we're going to do here? Multiply by 2. Do I have to multiply by 2? Is that the only option? You could divide by 1/2. Either way, if I multiply by 2 or divide by 1/2, what will be my next statement? Okay, so if I multiply by 2, the 2 and the 1/2 cancel out, and then I multiply the right side by 2 and I get t equals negative 14. Or if you divide by 1/2, remember dividing, if you take negative 7 and divide it by 1/2, how do you divide with fractions? You multiply, change flip. So you multiply by the reciprocal. So dividing by 1/2 is the same as multiplying by 2. Okay? So what does that mean then over here? What's my reason? It could be division property of equality, or it could be multiplication property of equality, and so either one would be acceptable. You still have the same statement, but either reason would have worked. So it doesn't matter. You just put one or the other, and both would be acceptable answers. And you're done. Just a two-step little equation, right? All right. Any questions there? Okay, moving on. Oops. So now we're going to look at some word problems, and we're going to do a couple word problems together today. Starting with this one. It says, what is the temperature in degrees Fahrenheit when it is 15 degrees Celsius? Solve the equation for F and justify each step. So again, it says justify each step, so that means we have to do what? Okay, show every single step, and what am I writing? A proof. So I'm going to make a 2-column proof. Statements, reasons. Yes, sir? Yes. So we're going to talk in 2.7. So when we get to section 2.7, we're going to talk about 2 different other kinds of proofs. And so we will look at those. They're called flowchart proofs and paragraph proofs. But the test will be 2-column. Okay, so you'll need to know the difference and be able to use the difference. But on the test, every proof you write for me will be 2-column. So that's why I'm starting it like this today, just to make that easier for you. It'll be very consistent. Okay, so the very first thing when you get to the word problems is you have to put everything that's given. Sometimes that's more than just the equation. So given, and then we're going to list everything that's given. So for sure they gave us an equation, right? F equals 9/5 C plus 32. Very good. It also gives you that the temperature for Celsius is how much? 15 degrees. So when we list that in our given, we're going to list that as C equals 15 degrees. Does that make sense? Because they said that it's 15 degrees Celsius. So they're giving us the C value. So you're going to list everything that they tell you in the word problem. Then you're going to decide how to solve for F. So that's your goal, solve for F. So what should we do first? Substitution property. And if you think substitution property in your mind, then go ahead over on the reasons and write it down before you forget what you did. So substitution property of equality. Make sure you put of equality. So number 2, when we substitute, we're going to have F equals 9/5 times 15 plus 32. Don't do 2 steps at once. That's substitution. What do we need to do next? Okay, we need to combine like terms. We are multiplying, but is this the multiplication property of equality? No, because we're only doing it to one side. We are going to add 32, but are we doing it to both sides? No, so it's not the addition property. All we're doing is combining like terms or simplifying, however you want to write that. If you're using simplify, I'm okay if you, or combine like terms, I'm okay if you do it all at once and just put simplify. Or if you want to do it in 2 separate steps and write simplify or combine like terms twice, that's fine too. What is 9/5 times 15? 27. So you can either put F equals 27 plus 32 and put simplify. Or you could have written it all down at once and said F equals what? 54. And I'm going to put that degree symbol since it's in degrees. Question? So 4th step, if I do it separately, what did I use the second time? Simplify. Oh, sorry. Is that the question? Sorry. 59. I was just taking your word for it. Are we good, Canyon? So, because you're doing it twice, you can write it once if you want to and do it all at once. So I would be okay if you had statement number 3 was F equals 59 and you wrote simplify, because that's what you did on all of this. Or you can simplify the first part and then simplify the last parts together. So I'll accept it either way. You can either do 2 steps, simplify twice, or each one or all of it together and write it one time. Okay? Questions on a word problem? Okay, moving on. Okay, so now we're going to start to look at some of these ideas for geometry, okay? So we've looked at some algebra equations, now we're moving to geometry. So it says, like algebra, geometry also uses numbers, variables, and operations. For example, segment lengths and angle measures are numbers, so you can use these same properties of equality to write algebraic proofs in geometry. So remember that two capital letters side by side with nothing above it means what? Distance. Distance. If it has something above it, then it's going to represent either a segment, a line, a ray. And in this case, it is a segment. Okay. So keep that in mind. Now we're going to look at an algebra problem that uses geometry. So first of all, they give you a picture. And this is all they give you. You're going to have to list at the very beginning everything you know from this picture. That's your given. So we're going to start with statements and reasons. Join you with me? Okay, so look at the picture. What is one thing in the picture that we know? Okay, and what is it all called? NO. So we're going to put NO equals 4x minus 4. Should there be a line segment above NO? No, never when you're using an equal sign. You're saying the distance from N to O is 4x minus 4. Okay, what else is given to us in the picture? NM equals 2x. What else is given? MO equals 3x minus 9. All of that is given in the picture. Okay, what did we learn in geometry that would let us write an equation for this picture? Hold on, Malachi, go ahead. Okay, so that is the equation that we can come up with. What geometry concept is that? It's not addition property. That's adding something to both sides. Okay, part plus part equals whole. What's the name of that? Something. It's not just the addition postulate. You're missing a part there. It's close. Close. You got it kind of messed around there. Segment addition postulate. So remember I told you, you're going to have to know the names when we get to proofs. I will not accept part plus part equals whole. You can think that, but you have to know the name. This is a segment, and we're doing the segment addition postulate. Now stop for a second. That is not our next step. Okay? Segment addition postulate does not say 2x plus 3x minus 9 equals 4x minus 4. What does segment addition postulate say on this picture? Nope. What is segment, anytime we did segment addition postulate in our notes, do you remember that we had a problem one time on our homework that said draw a line segment, put D, E, and F on your line segment. E was in between D and F, and you were supposed to write the segment addition postulate. The segment addition postulate is not the algebraic equation. The segment addition postulate is the distance plus the distance is equal to the whole distance. So what you have to write down first is not the equation. You're skipping a step if you do that. You have to write down the part NM plus the part MO equals the whole part NO. That's the segment addition postulate. Okay. Then you can use what you said. What process are you using to come up with that equation now? Nope. Addition, okay, remember ye, addition property is adding something to both sides of an already given equation. So if you're trying to move something from one side to the other and you add it to both sides. Substitution. Now we're going to plug in this value for NO, this value for NM, and this value for MO to write that equation. So we're going to use substitution property of equality. Okay, so what is my equation going to say? Very good, I'm just listening. and writing. So 2x plus 3x minus 9 equals 4x minus 4. We substituted it in. Questions to this point? Now this is just an algebra proof from here on out, right? We're just going to solve for x. The part that's the geometry is the segment addition postulate. So that's the new part that we had to add in. Any questions up until here? Okay, I'm going to finish this proof over here on the board. So if you're watching the video, just listen. I'm writing down what I say since I'm running out of room. So what would be our next step to solve for x? Combine like terms. What can I combine? 2x plus 3x. So what is my next statement, number 4? Say it again, Remy. Okay, remember, we're not showing our work. We're not putting anything else down. We're just writing what comes next when we combine like terms. This is not given. This is simplify or combine like terms. Okay, and I'm lazy, so I'm going to write simplify every time. All right, what do you want to do next? Okay. Okay, you can use addition property. If you do addition property, what are you actually adding? Okay, you could add 4 to both sides. Since I heard subtract 4x first, I'm going to do that, which means if I subtract 4x, what property am I using? Subtraction property of equality. This is where if you're comparing your answer to your friend's answer, or you're looking at it in the back of the book, you may have a different answer and still have a correct answer because you may do it in a different order than they do. Okay? So when you look at the proofs, and I'm going to warn you, the book that we've had for a long time, some of the proofs are not very good in the back. They have mistakes. So if you do a proof and you think that what you did was right, but the book has something different, send me a text. Send me a picture of your proof and ask me if it's okay, and I'll let you know. Because the back of the book is not always correct in this one, on these. All right, so this is number 5. And you said simplify or combine, or no, sorry, subtraction property. So what we're subtracting the 4x, so what would we end up with? All right. And again, that's not the only option, but that's what we chose to do. So from here, our 6th step would have to be what? Addition property. So we're going to add 9. Addition property of equality is our reason. And what's going to be our statement number 6? X equals 5. And are we finished? We are finished. When you have x equals or m equals or whatever variable equals, you're done. What if we would have subtracted the 5x over? Very good, Yi. So then we would have to flip it. And what's the reason we use if we flip it? Not reflexive, not transitive. Symmetric property. Like symmetry. You're going to flip it over. It's going to be symmetrical. It's going to be symmetric property of equality. So if we have to flip it, that's what we'll use. So if you subtracted 5x, you would have to have a division property in your work, yes, but you still have to use symmetric at the very end. So if you subtracted, Liam, I would have -9 equals -x minus 4, right? Add 4, I would have -5 equals -x. Then you would either divide or multiply by -1, so you could have division or multiplication, but you would have to have that next step, 5 equals x. And then you would have to flip it over to get x equals 5. So we would have subtraction property, addition property, either multiplication or division would work, and then symmetric property. Does that make sense? Okay. So again, lots of different ways you can solve an algebra equation and still have the correct answer. Okay, one more here, geometry type problem. Again, this time they just give us a picture and they want us to write a justification for every step. So I'm going to go back and make sure you can at least set it up correctly with all the geometry. Statements. No, you have to write it out. No abbreviations at all anywhere except for the equal sign. Okay, statements and reasons. Okay, number one. What's the very first thing we're going to list? Okay, the given. So what is given to us in this picture? Okay, do I write angle ABD? What am I missing? The M, because you're going to tell me what the measure of angle ABD is equal to. So don't forget the little picky notation, okay? Anytime you're using an equal sign for an angle, you should have the little m for measure. If you're naming the angle, then you're not using an equal sign and you take off the little m. Oops. Okay? So measure of angle ABD equals what? 3x plus 5 degrees. Okay, what else is given? Angle DBC. So measure of angle DBC is equal to what? 6x minus 16 degrees. What else? Okay, watch this right here, because sometimes in the book that's kind of hidden and you don't really notice it right off the bat, but they are giving you that. Measure of angle ABC is 8x. What is ABC in the picture? The whole thing. Is everybody good with that? All right, what do we do from here to come up with an equation? We have to have something to substitute it into. We don't have anything to substitute it into yet. Angle addition postulate. Be careful with your picture. We were dealing with a segment, but now we're dealing with a picture of an angle, but it's the same type of postulate, but it's called the angle addition postulate. Again, be very careful. Angle addition postulate does not contain variables. It's not your actual algebraic equation. You have to think about the picture first. So what would we write down? Okay, measure of angle ABD. Good, plus the measure of angle DBC equals the measure of angle ABC. So you're writing it down by looking at the picture first. Are we good with that? Okay, now we're ready to do what? Substitution property. Don't forget to put substitution property of what? Of equality. I will count off if you don't have of equality. All right, so when we substitute this in, we're going to have what? 3x plus 5 plus 6x minus 16 equals 8x. Make sure you're substituting it into the correct locations to get your equation correct. Yes, ma'am. We don't have to really have it either place because it's already in our picture. So when we solve for x, our x is really not in degrees. Our x is just a number. It's the entire angle that's in degrees. So you don't have to worry about that degree symbol. Okay, what do you want to do from here to solve? Simplify, combine like terms. All right, and what can we combine or simplify here? 3x and 6x is what? 9x. Can we go ahead and combine something else too? Yes. What's 5 and negative 16? Minus 11 equals 8x. So again, you could do those in two separate steps, or you can just do them all at once and just put simplify. What do you want to do from here? I heard add 11. Okay, what are you going to subtract if we subtract? Okay, so either way, I'm going to go ahead and subtract the 9x just to have on our notes that whole symmetric property. You wouldn't have to use that if you chose to add 11 first, because then when you subtract 8x, you'll already have x equals. So it's a little quicker that way, but just to have an example where you do have to flip it, I'm going to work it the other way, okay? Again, you do what is easier for you, but I'm going to work it this way. So I'm going to the board. This is number 5. Running out of room on the whiteboard. So I'm going to subtract the 9x instead. So if I subtract 9x, what am I left with here? Negative 11 equals negative x. And that was subtraction property of Okay, what do we do next? Division property or multiplication property. It doesn't matter. You're either going to divide or multiply by a -1. What will your statement be? 11 equals x. So again, it doesn't matter whether you put division property of equality or whether you put multiplication property. But again, you're not finished if this is what you have. You have to flip it over. Every problem tonight, you have to make sure it's x equals. So we have a 7th step of x equals 11. And what's our reason? Symmetric. Symmetric flips. Symmetric property of equality. Okay? Symmetric flips. Questions here? All right. We should be getting close. So the last thing that we're going to look at today is these three properties again, reflexive, symmetric, and transitive. But now notice it says of congruence. And again, I'm going to let you use the symbol for congruence if you want, so that you don't have to write it out. But you better make sure I can tell that it's a congruent symbol and not an equal symbol. Okay? So make sure you're careful. Reflexive property, symmetric property, and transitive property. This is more for the geometry where we're headed next lesson. Reflexive property, remember, says something equals itself. A equals A, 5 equals 5, 2 equals 2. Reflexive property of congruence says that a shape is congruent to itself. So line segment EF is congruent to line segment EF. It's when we are talking about the shapes now, not the actual numbers. Everybody with me there? Symmetric still flips. So it says if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. But notice we took off the little m's and we're not using an equal symbol. We're talking about the actual shapes congruent to a shape. And then transitive has three parts. It's got that if PQ is congruent to RS and RS is congruent to TU, looks like the law of syllogism because it has the RS on both. So we get rid of the middleman and say PQ is now congruent to TU. So there's three separate equations in transitive property. Questions? Here's another way you can remember this that might help. RST. That's alphabetical, right? RST. 1, 2, 3. Reflexive has one equation. Symmetric has two equations. Transitive has three equations. So RST 1, 2, 3. If that helps you, maybe you can kind of R is 1, S is 2, transitive is 3. RST 1, 2, 3. Alphabetical and numerical. Okay, I'm going to emphasize this one more time. Numbers are equal, figures are congruent. AB equals AB is reflexive property of equality. AB congruent to AB with line segments is the reflexive property of congruence. So this is equality numbers. This is figures congruent. Are we clear? And I made a big deal about that way back in section chapter 1 when we were talking about naming shapes, about when to put those line segments and when not to put those line segments, and this is where it's going to come up again. Okay? So the next thing they're going to ask you to do is just simply identify the property that justifies the statement. They're not asking you to write a whole proof. Just for each part, what is the property? So we'll go through this one together, and then I'm going to have you do the next one on your own, and then we're going to work one problem off your homework together. Okay? So identify the property that justifies each statement. Look at part A. Angle QRS is congruent to angle QRS. Reflexive property of congruence. Very good. Again, do not abbreviate. The book is going to abbreviate all over the place. Lashley says you may not abbreviate. So reflexive property of congruence. What is part B? If 1 equals 2, then 2 is equal to 1. Symmetric property of, careful, equality. Look at the symbol in the statements. That's going to tell you whether to put of equality or of congruence. This was a congruent symbol, so it's of congruence. This is an equal symbol, so it's of equality. So it's symmetric property of equality. Most misspelled word is symmetric property. Symmetric. There are two M's. Symmetric has two M's. S-Y-M-M-E-T-R-C. Symmetric. Two M's. So be careful there. All right, C. AB is congruent to CD. CD is congruent to EF. So now AB is congruent to EF. Transitive property of congruence. Good. Notice there's three. It's like the law of syllogism. The part they have in common gets canceled out. But we call it the transitive property of congruence. And then the last one, D. What is D going to be? Good. Reflexive property of equality. 32 is equal to itself. There's an equal sign. So it's reflexive property of equality. Now I want to warn you of one thing. What is this? It is one of them. Okay. If you're unsure, how many equations are written down? 1, 2, or 3? 1. This is one congruent symbol. Okay? Remember, RST, 1, 2, 3. If there's only one equation or congruent statement, it can't be symmetric. A lot of students will think symmetric because what did they do? They flipped the letters, but that's just a different way to name the same shape. It's still the same shape, right? So this angle is being congruent to itself because it's the same angle. So that is reflexive property of what? Congruence. So just because they changed the way they named it, if it's the same shape and there's only one equation, it can't be symmetric. Symmetric is two equations. You take one and then you flip the whole equation over. Okay, you guys try the last four. And when you're finished, you need Core Math page 74. Again, when you get finished with these four, you need Core Math page 73, 74. Yeah, 73, 74. But we're going to go over these as soon as everyone's done. Raise your hand if you are not finished with these four. Let's check these, and then again, the core math page you need is 73, 74. Okay, 4A. What did you get for 4A? Good. Symmetric property of equality. Make sure you spelled it with 2 M's. Symmetric. 2 M's. All right, what about 4B? Reflexive property of equality. Again, remember you're looking at the symbols to know whether to put equals or congruence. 4C. Transitive property of equality. The A's are the same. We get rid of them. We get 0 equals X. So that is transitive property of equality. And the last one, 4D. Symmetric property of congruence this time because the symbol is congruence. Again, if you're getting confused, remember 1 equation, 2 equations, 3 equations. R, S, T, 1, 2, 3. Okay, that helps a little bit when you're just picking out which one it is. Questions? Okay, we're going to look at one of the word problems on your homework. So look at core math page 73 and 74. And if you didn't bring your core math page, be aware, that's a discipline notice for not bringing your supplies to class. You need to have your stuff every single day. I cannot tell you when we're going to need it and when we won't, so bring it every day. If you don't have it, you better take detailed notes because we're going to fix some things on our core math page and we're going to do some of it together. So first of all, look at side page 73. There is a typo on 73 and I want you to fix it. So core math page 73, number 4. And we are going to look at this together. First of all, you are setting your problems up as 2-column proofs every time. So even though this doesn't have a 2-column proof, you're going to go ahead and make it a 2-column proof. This is going to be statements on the left and reasons on the right. The book doesn't do 2-column for algebra proofs, even though they write them in 2 columns, but then when they get to the geometry proofs, they're all 2 columns. So it's better to just be consistent. What else do we need to do in a proof besides put statements and reasons? Number them. So we're going to number. Now stop for a second. You're missing a step here. Okay? So we're going to add a little arrow here. And then I don't have room right there, so I'm going to come down here and put step number 1 because they're missing the very first step. Okay? And the same thing here. I'm going to put a little arrow and then come down here and put number 1. And list my reasons. If you have room, you can fit it in up there, but I wrote statements and reasons too big. So our first reason is typically what? Given. And what was given in this picture? Hj equals 7x minus 3. What else? Hi equals 2x plus 6. What else? Good. Ij equals 3x minus 3. They did not list the given on this problem. So we're listing the given, and then go back up here. This will be statement number 2, number 3, number 4, number 5, number 6, and number 7. And then the same thing over here. Reason 2, 3, 4, 5, 6, 7. So I'm just making you set it up as a 2-column proof, but they left off the given. Any questions on that? And then it's just like what we did today, so you should be able to work that. Okay, I'm going to flip it over. Anybody need more time before I flip it? Okay, I'm going to wait a second. But we're going to look at one of the 2 on the back, numbers 1 and number 2. We have 2 word problems there, and I'm going to do number 1 with you. Okay, and then I'll let you do the rest on your own, and you'll have the rest of the period to work. I have a slip for you in a second, but yes, you're going to be doing both sides. Anybody still need more time? Okay, I'm going to flip it over. So we're going to look at number 1 together. So again, these are a little harder word problems, but Same idea that we did on the little word problem we did in the notes. You're going to list, make a 2-column proof because it says justify each step here. So we're going to write a 2-column proof. Statements and reasons. And we're going to number every statement and every reason. Okay? You're going to have to pick out everything from the word problem that's given. So we're going to go line by line reading the sentences. Because of a recent computer glitch, an airline mistakenly sold tickets for round-trip flights at a discounted price. The equation in parentheses p plus 2 is equal to 3,298 and 75 cents. Relates the number of discounted tickets sold in the price of each ticket P and the tax per ticket T. So first of all, what's one thing in that sentence that we could pick out and write down as a given? The equation. So in parentheses, P plus T equals 3,298.75. Okay? In that sentence, they tell us some other things as well. What does N stand for? Okay, the number of discounted tickets sold. What does P stand for? The price of each ticket. And what does T stand for? Tax per ticket. So now we're going to read on and see if they give us any of that information. We don't need to list that in our proof yet. We'll wait till we see what they give us. So it says, what was the discounted price of each ticket if 1,015 tickets were sold? So what variable are they telling us is 1,015? Tickets sold. So what is it? Yep, the number of discounted tickets sold is N. So we would say N equals 1,015. Okay, what else do they tell us there? The tax per ticket was $1.39. So what stood for tax per ticket? T. So T is equal to $1.39. And what are they asking us to find? P. So now we have our given. Don't forget to put given as your reason. And we're ready to set this up and solve. So what do we do first? Plug it in, and we call that substitution property of equality. And so when we substitute it, we'll plug in the 1,015 for N. We don't know P, so we'll leave that. Plus, the tax per ticket was $1.39, and that equals 3,298.75. Now, these are some large numbers. I do not expect you to have to do all the math by hand. You can use a calculator if you need to on some of those harder ones, but you still have to show every step in your proof. Okay, so what would we do next? Distribute. So step number 3, reason would be distributive property of equality. If we distribute, what do we end up with? Okay, so 1,015p plus, does anybody want to calculate 1,015 times $1.39 for us? $1,410.85. Okay, and that's going to equal 3,298.75. And then what do we do? Okay, number 4, subtraction property of equality. And when we subtract, we end up with 1,015p equals what? You can either come over to the side and actually do the subtraction, or you can grab that calculator and subtract them. Let me know if you get an answer before I do. Or make sure I get the same answer you do. Anybody got an answer? How did you get negative? You should be doing Okay. So is this right? 1887.9? All right. So again, you can do that math over to the side if you need to, but you can also use your calculator for the bigger numbers. Okay, what do we get for that? What do we do next? Division property. So statement number, or reason number 5, sorry, is division property of equality. And now we're going to divide by 1,015. And so our final statement number 5 should be P equals what? 1.86. And that's going to be $1.86 since we're dealing with the price per ticket, right? Which would be awesome if the computer glitch gave us a round trip ticket for $1.86. Okay, questions on how to do it when it's a word problem and you got to pick it out, Luke? The answer when we divided was $1.86. So 1.86. Okay, so your assignment is to do both the front and back of this, and then there's a few problems out of the textbook. I think there's like 7 or 8 problems out of the textbook. And you have about 15 minutes. So finish working on this or get out your textbook and work on the textbook page. You may listen to music. And this is due next class period. Jordan, I'm worried about you, dude. You're really tired lately. What happened? Oh, I'm so sorry. I hope you feel better. Okay. I am sorry.